this is MK and I welcome you all to my YouTube channel Physical Universe with Zero. For update of my upcoming videos, please subscribe my channel and press the bell icon button. So let us now start our discussion, which is numerical 2. This numerical is mainly based upon relative velocity and is also known as flag wind problem. So here is our question. In a harbor, wind is blowing at the speed of 20 meters per second and the flag on the mast of a boat anchored in the harbor fluttered along the northeast direction. If the boat starts moving at a speed of 15 meters per second to the north, what is the direction of flag on the mast of the boat? So you have to find what will be the direction of flag on the mast of the boat when boat will starts to move. So as you know that the direction of flag is always along the direction of wind. So in this case we have to mainly find what is the direction of wind with respect to boat, or you can say that what is the direction of relative velocity of wind with respect to boat when boat starts to move. So here is the solution. Velocity of wind, it is given 20 meter per second towards northeast. We are considering it as VW. Second thing is your velocity of boat. It is given 15 meter per second towards north and we are considering it as VB. The direction of flag or wind with respect to boat, that is question mark, means we have to find this. And also to find the direction of relative velocity of wind with respect to boat, first we have to find what is its magnitude. So first we will find relative velocity of wind with respect to boat. We are writing it as VWB. So first we will find the magnitude of VWB, then we will find its direction. As you know that relative velocity of wind with respect to boat, this will be equal to velocity of wind minus velocity of boat. It is VW minus VB, and this can be further written as VW plus inside bracket minus VB. So we will use graphical method to find VWB. So here is our graph. You can see here we have considered four direction: east, west, north and south. So this blue arrow is indicating wind velocity, that is VW, as it is along northeast. So you can see that this arrow is along northeast direction. And next thing is this red arrow which is written as VB. This is the velocity of boat. So this red arrow is indicating the velocity of boat and it is towards north, and the blue arrow is indicating the velocity of wind and it is towards northeast direction. As you can see in above equation, to find VWB we have to add VW with negative of VB. So to find VWB we need VW and minus VB, but as you can see that here we have VW but we don't have minus VB. Instead of minus VB we have VB. So how to get minus VB? As you know that if you will invert the direction of a vector, then you will get its negative. So to get negative of VB, you will simply invert the direction of red arrow, which is indicating the velocity of boat. So to get minus VB, simply invert the direction of VB. So here you can see that we have inverted the direction of red arrow so that we get minus VB. So now we have our two desired vectors, VW which is indicated by blue arrow and minus VB which is indicated by red arrow. Now we will simply add these two vectors to get VWB. and for addition we will use triangle law of vector addition. So this is our first vector, which is VW and is along northeast direction. Its magnitude is 20. And this is our second vector, minus VB, whose magnitude is also 15, and it is towards south. So we have placed our second vector, that is minus VB, such that its tail coincide with the head of first vector, that is VW. So now this is A plus B. So the resultant will be from tail of first vector, that is VW, to the head of second vector, that is minus VB. So this light blue arrow, that is VWB, this is our resultant vector or relative velocity of wind with respect to boat. So now we have our relative velocity of wind with respect to boat. So as you can see, its direction is towards east, so answer will be towards east. You can conclude here, but we will find correctly. So this angle is 45 degree, it is given, and this angle we are considering here phi. We have to calculate this angle phi. So phi is the angle with which flag will flutter when boat will start to move, and this is with respect to the northeast direction. So first we will find what is the magnitude of VWB. So as you can see in above equation, since VWB is the resultant velocity or resultant vector of two velocities VW and minus VB, as you know that the resultant vector is given by root over a square plus b square plus 2ab cos theta. So here you can see we have used VWB is equal to root over first vector is your VW, so VW square plus second vector is VB, so plus VB square plus 2 into VW into VB into cos 135. So you can simply conclude that the angle between VW and minus VB is 135. So if you will put the value of VW and VB in above equation, you will get simply VWB is equal to 14.16. So the magnitude of this resultant vector, that is VWB, is simply 14.16. Now we have got its magnitude. So we will finally find phi. So to find phi, you can use sine law. If you remember sine law, then you know that sine of angle divided by the length of side in front of that angle is a constant for a given triangle. So here sine A by A, sine capital A, where capital A is the angle, divided by small a, where small a is the length of side in front of angle capital A. This will be equal to sine capital B by B, where capital B is another angle and small b is the length of side in front of capital B. So if you will use this equation for this triangle, now we have all the three sides. We know the value of VWB, it is 20. We also know the value of VB, it is 15, and we also know the value of VWB, which is we have calculated and is 14.16. And we also know one angle is 45 degree and another angle we have considered phi, so we have to find phi. So what will be your formula? Simply sine of, if you will use sine law, then sine of high divided by VB. This should be equal to sine of 45 degree divided by VWB. So here you can see in your answer, sine of phi divided by VB is equal to sine of 45 divided by VWB, or you can simply put the value of VB and VWB. So you get sine phi by 15 is equal to sine 45 by 14.16, or you get, if you will simplify, you will get sine phi is equal to 0.75. Hence phi is equal to sine inverse 0.75. Therefore phi is equal to 48.5 degree towards east with respect to northeast direction. So you can say it is approximately towards east direction. So the correct answer is the flag will flutter in a direction of 48.5 degree towards east with respect to the north.
I hope this video will help you to improve your interest and understandings of physics. If you have any question or confusion regarding any topic of physics, please tell me in comment box below this video, and I will try to help you in my next video as soon as possible. To support, please subscribe my channel and share this video link. Thank you and have a nice day.